this video, I'm going to review the word problem study guide for Unit 4. So the first page of the study guide, it goes over how to solve a word problem. Make sure to read your word problems, circle the numbers, highlight the operation words, set up the problem, solve, and label your answer. I also included a picture of the notes that you have taken in your notebook for the keyword operation words. And then at the very bottom down here is just all the steps for solving fractions. So the first 4 problems on your study guide were just determining what the operation was. So the first one says Tom and Jimmy ran a race. Jimmy ran 2.5 miles and Tom ran 2 1/4 mile times as far as Jimmy. How far did Tom run? Well, if I highlight my operation words in this one, the operation word is times as far. And you can also add in, if you wanted to, you could add in as far as Jimmy. Because the times word tells you that it's going to be multiplication between the two fractions. So that's how I know that that one's going to be multiply. Number 2, Mr. Garrett bought a block of fudge that weighed 1/2 of a pound. He cut the fudge into 3 equal pieces. What was the weight of each piece of fudge? So because he is cutting the fudge, that operation is going to tell me that it is division. If you look at the keyword, division. So it is a division problem. I'm going to take the 1/2 and divide it by 3. For number 3, Terrence and his sister shared a pizza. They ate 5/8 of the pizza altogether. And if Terrence ate 1/4 of the pizza, how much was left for his sister to have eaten? So it wants to know how much was left. So you have to take the 5/8 and the 1/4, and then you're going to end up subtracting them because it wants to know how much they have left for his sister. So you would subtract them. And that's your keyword. Number 4, Jonathan and Sammy worked at their grandmother's apple orchard last fall. Jonathan picked 2.5 bushels of red apples and Sammy picked 8 1/2 bushels of yellow apples. How many bushels of apples did they pick all together? Your keyword for that one is pick all together. And that's telling me that it is an addition problem, so I'm going to add. The bottom 4 problems is where you actually had to solve. So for number 5, Johnny has 6 1/4 feet of material for a costume and he needs 10 2/5 feet for the entire costume. How much more material does he need? So remember, we're going to circle our numbers. And then I'm going to read the problem again. Johnny has 6 1/4 feet of material for his costume. He needs 10 2/3 feet for the entire costume. Okay, that's how much he needs in all. So it says how much more material does he need? So because it's asking how much more, and I know that I need 10 2/3, but I only have 6 1/4, how much more is telling me to subtract them to figure out how much more do I need? So I'm going to do 10 2/3 minus 6 1/4. And I'm going to turn them improper. Anytime I see a mixed number, I'm automatically going to turn it improper. Multiply at the bottom, add at the top. So 3 times 10 is 30, plus 2 more gives me 32 over 3. 6 times 4 is 24, plus 1 more gives me 25 over 4. Now I need to find a common denominator. And when I find a common denominator for those two, my common denominator can be 12. And remember, you can use a multiplication chart for this. So I'm going to do 4 times 3 is 12. So if I do 25 times 3, that gives me 75. And then 3 times 4 is 12. So I'd need to do 32 times 4. I don't know it, so I'm going to write it out to the side. 32 times 4. 4 times 2 is 8. 3 times 4 is 12. So that gives me 128 over 75. Now I'm going to subtract those. 128 over 12 minus 75 twelfths. Well, they're both twelfths, so how many twelfths do I have if I do 128 minus 75? 8 minus 5 is 3. I have to borrow here to make this 12. 12 minus 7 would be 5, so I get 53 over 12. Let's look at the answer choices and see if any of those can help me. So I do have, it can't be this one because I have a denominator of 3 and my current denominator is 12, so it can't be here. 12 doesn't go into 53 4 times, so it can't be this one. So I can turn them in proper and see if I can find one that matches, because to me it's telling me this doesn't simplify. So if I multiply this, I can do 4 times 12 gives you 48, plus 5 more gives me 53. So I have 53 over 12 for this one. So more than likely, that one's going to be our answer. Because 16 times 12 is going to be like a crazy number there. So it can't be this one. That's going to be way too much. Okay, looking at the next one, about how many 2-foot boards can be cut from a 7 3/4 foot board? And it's saying about, so it's not going to be an exact number, but I need to get as close to as many whole boards as I can get. So I need to reread it one more time, and then I'm going to highlight my keywords. So it says about how many 2-foot boards can be cut from 7 3/4. So I'm going to cut my boards. And when I look at the operation where it's cut, tells me it's going to be a division problem. And you need to think to yourself, okay, how many boards, how much am I starting with? How long is the whole original board? Is it a 2-foot or is it 7 3/4? It's 7 3/4 is what you're starting with. And then I'm cutting it into pieces that are 2. So in order to solve this problem, I need to turn improper first always, and lonely whole numbers get a denominator of 1. 4 times 7 is 28. 29, 30, 31 over 4 times 2 over 1. Now, I cannot, oh, I'm sorry, not times, divide. I can't divide fractions, so I need to do keep, switch, flip. So it's going to be 31 over 4 times 1 over 2 becomes 31 over, multiply, I get 8. And I have to think to myself, okay, how many times can 8 go into 31? 8 can go into 31. 8 can't go in 8 times because that would be 64. That's too much. 8 times 3 would be 24, so that could work. 8 times 10 would be 80, so that's too much. And this would be 40, so that's too much. So it would be only 3 boards. And you could also do it by doing long division. 8 goes into 31. You could only go in 3 times, which would be 24. And when I subtract those, you get 7 left over. So it only goes in 3 times perfectly, and then I'll have a remainder here, which is okay because it says about. For number 7, it says, according to the table, what is the total distance Frank walked for the 3 days? So it's looking for total distance. And total distance tells me it's going to be an addition problem. So I'm going to look at my fractions, make sure everything is improper. So if I turn this guy improper, that becomes 3 over 2. And then I'm going to stack them all up. 3/4 plus 3 over 2 plus 2/3. And I'm going to look at my denominators. I have a 4, a 2, and a 3. You can look on your multiplication chart what goes into 4, 2, and 3. And it would be 12. So I can change all my denominators to 12. 3 times 4, so that makes this 2 times 4 is 8. 2 times 6, so that makes this 3 times 6, which is 18. 4 times 3, which makes this 3 times 3, which is 9. And then I can add them. So that makes this 9/12 plus 18/12 plus 8/12. So if I add all those together, 18, and then 9 plus 8 is 17. So that gives me 35. 12. And then if I can look at my answer choices to see, okay, well, I have one with a denominator of 12 that matches, so let's check it. And maybe I don't have to simplify. 12 times 2 would be 24. 24 plus 11 would be 35. So that's why this one should be the answer and the other two won't match. And I knew that because my denominator is 12. The first one doesn't have a denominator. The second one doesn't have a denominator. Neither does the last one, a denominator of 12. All right, number 8, it says use the fraction model to help you solve. So there's our model. A girl had 2/5 of a batch of cookies in a cookie jar, and she decided to eat 1/3 of the cookies. What fraction of the cookies did she eat? Let's read that one again. A girl had 2/5 of a batch of cookies in a jar. She decided to eat 1/3 of the cookies. What fraction of the cookies did she eat? So I'm going to circle my fractions, and then I need to highlight my keywords. So she had 2/5, and then she decided to eat 1/3 of the cookies. And it's asking what fraction of the cookies did she eat. So I'm going to say of the cookies did she eat. And if we read right here, it said she decided to eat 1/3 of the cookies. And we have to think, well, she originally had this many cookies. She had 2/5 to start with. This of, when it's referring back to this number here, the of tells you an operation, which is multiplication. You can fill in that circle. Because I wanted 1/3 of the 2/5 of the cookies. And of tells you to multiply there. You can also look at this model. When we model like this means multiplication. And they gave that away by giving you the model. So you can either solve it with multiplication, times 2/5 would give you 1 times 2 is 2, and 3 times 5 is 15. So that would give you the answer of 2/15. Or you could look at the model and look at the overlap versus the total. And the overlap, there are 2. And the total, there are 15. So I still get the same answer. It's just 2 different ways of solving it. And if I look down at the answer choices, the first one is 2/15. So that is your study guide. If you have any questions before you take your test, make sure you let your teacher know. And you do not need to submit it because remember, this is optional.